Hello, in this video I'll show you how to manually classify documents on a dataset you have uploaded to ICS, and what happens to the machine learning models that are updated automatically by ICS, and how you can then use those machine learning models to automatically classify your dataset. So let's start, and this is our dataset page. We have our movie review dataset, and let's say that we want to classify it by sentiment, so positive and negative movie reviews. So we go here to the menu and we have the browse and code option. We click it and we are now in the main page of the of ICS, the main page that is used to manually classify documents. So in this page, the first thing that we see is document, and here we see a counter, or that lists the total number of documents that we have in the dataset, and then we can browse documents we have in the dataset, and we can enter any number to get that document in that position. And so this is the main document, and we want to perform sentiment classification of this review, and so we have to define a classifier. If we click here to select a classifier, we see that no classifiers are currently defined. So let's move to the classifiers page. This is the classifier page, and we see that there are no classifiers defined. So we create a new classifier by clicking here. Then we set the name of the classifier, we can call it sentiment, and we list the names of the labels that we want to assign to documents. So we can say positive and negative. This will be a single label classifier, so we have two labels and we always want to assign exactly one label for any document that we label. So this is a single label classification. We create a classifier, and now we see here the classifier is available with its name, the labels, a description that we can change to get a human readable description, the mode of classification, single label or multi-label, the size, which means the number of training examples that we have produced, and so that have been used by the machine learning algorithm to fit the classifier, and whether or not this is a public classifier, so available for other users to perform classifications. So we go here to the menu, we see the many options that we have to modify and work with classifiers, and this will be the subject of another section, another video. Okay, so let's move back to the dataset page and to the browse and code page to start our classification of documents. So here we have our dataset, we go for the browse and code. Now here we have our sentiment classifier available, and here you see this is we have the name, letter S, which means this is a single label classifier, and these two numbers tell us that we have not yet labeled any document with this classifier on this dataset, and so we still have 25,000 documents to be labeled for this dataset and this classifier. So we can start, and so now we have to, whenever we select here a classifier, the classifier is shown down there, and here you can see the name, the fact that it is a single label classifier, and the labels. So whenever I click here or here, I assign the label, and here you see that there is a suggestion, this light bulb and yellow color of the label. This is a suggestion from the automatic classifier, so the machine learning classifier. Whenever you create a machine learning classifier, this is generated as a random classifier, so obviously the first suggestion that you'll get will be random, and so you get sometimes a correct suggestion, sometimes not. As long as you continue labeling documents, you'll get more and more accurate suggestion. You can go on doing your labeling without looking at suggestions, so you can deselect these, and so whenever you browse the documents you won't see any light bulb, any suggestion here. This does not mean that if you click on a document and assign a label and assign it, you are not updating the machine learning model. These are two separate activities related to the machine learning component of the system. So let's turn on suggestion, which is always interesting to see them in action. And another part that is relevant when you work on doing manual classification is the way you move to the next document. And by default, so here you select the browsing mode, and by default it is set on active learning. This means that the next document is selected by those documents in the dataset that are the hardest for the machine learning model to take a decision on, so those with the lowest confidence scores. And so if you follow this browsing mode, any label that you assign to document is a label that gives information to the machine learning algorithm on examples that are hard to classify. So the idea is that you provide valuable information to the model. But you can go on and follow, for example, the upload order, and whenever you click, you ask for the next document, you see that what is increasing here is the number of documents. You just progress one after the other by ID, by upload order, and then you can have the option to move through the dataset in order skipping the labeled documents. So the idea is at this moment, given that we have no labeled document, this does not change anything. But if you have a lot of labeled documents, it may be hard to find those that are missing a label. So by processing the dataset this way, you quickly identify those that are not labeled. Then there is reverse order for the unlabeled document, and then random. So random document really selects documents randomly, and you can restrict these to work on the unlabeled set of document. So here you see the document changes. I'm not clicking, I'm just pressing the right arrow on the keyboard, which is a shortcut for give me the next document. So the idea is that you read the document, you click on the label, and you press the right arrow to move to the next, so you don't have to move back and forth from the labels to the next document button. And when you work with active learning browsing mode, by default, by definition of the process, you will never be presented with documents that have been already labeled. So here the unlabeled option is already active. So we can start doing some labeling. Now I will accelerate the video while labeling, let's say, 100 documents, and then we will see how the machine learning model performs. Now I have labeled 100 documents, and we can see here that given that I was showing suggestion, an agreement history is recorded on the last 50 labels assigned. And so the agreement, the percentage of the agreement is 46%, which is quite low. But we have to take into account that I was using an active learning policy. So I was not really randomly sampling across the dataset. I was searching for hard to classify, the algorithm was searching for hard to classify documents, so the accuracy is lower than the expected value on the whole dataset. So to check what is the current an estimate of the current expected accuracy on the dataset, I can move to a different browsing mode, for example random unlabeled, and I can classify 50 more documents and check on that window of 50 random documents what is the recorded accuracy. So I will let the video go faster and we will see after the 50 labels what accuracy we have got. I have labeled 50 more documents using a random sampling mode, so this can be considered a set of documents that is representative of the whole dataset, even though it is very small. And you see that agreement on these last 50 labels that I have assigned with the agreement of the machine learning classifier is 72%. So this can be a proxy of the accuracy of the classifier right now. So this is an early value for the final accuracy that we can expect. We have labeled just 150 documents. The experiment on this dataset tells us that when we reach about 1000 labeled documents, the accuracy is more or less 82%. So we have still room to improve the quality of this classifier, yet we are for sure distant from a random classifier, so the suggestions are already good suggestions. So we can keep going on doing our manual labeling and looking at suggestions with more confidence as long as we go on. And there is another option, there is another aspect that it is interesting in this browser code interface, which is the filtering option. So this allows you to enter a string such as worst movie ever, and so any document that is presented is matching this search string. So if we search for this string in the page, you'll see that this string always appear in the document. And so, for example, this is an interesting case. You can type this sentence to quickly search for strong negative reviews, easy to mark. But if you check this review, it contains this expression, but this is then to negate it and say that this is a very good movie. And so this is actually a positive review, and you can see that the hint, the suggestion is for the assignment of a positive label. So we can click and confirm this intuition from the machine learning model. So here you can exploit this filter to, whenever you have some type of content that you're searching for that will allow you to label your data more quickly, or to spot some specific case that you would like to add to your training set. So this is an helpful function that you can use, and whenever you search for something that is not in the text in the dataset, you will get an alert that says no documents contain this string. So now we can move to another way of doing classification, which is live classification. In this interface, when you select this option, you have to select a single classifier, which in this case is sentiment, and then you are presented with a tabular view in which every row is a document followed by the list of labels that you can assign. And so you read the document and you assign the labels, and this view is better suited when you have short documents and you want to compare them to take your decisions. But we can see that we can use also in this case, and you see that some labels have been already assigned using the other interface, and whenever one label is assigned, it will pop up whenever the document is shown, even if multiple users are using the ICS. And so in this case, then you have obviously suggestions. So there is this review, which is negative review. So we click here, and then we go on scrolling, and here you see, for example, what happened, that this label, this suggestion, changed from being positive to being negative, just because the model has been updated after my previous label assignment, and so the active machine learning model decide to change its own decision. So we can go on assigning label manually on these documents, and there is a paged view, so we can see all the data set. And also in this case there is the text filter that we can use to work on a selection of documents. And so we can, if we know that we want to focus on some selection of documents matching some string, we can do it this way. And this is useful especially in this view when you have some very short text, such as the name of a brand, and so you mimic some kind of rule matching. You do the filter, you have the documents, you quickly confirm or pick the right label, and so you accumulate a large amount of labels for your data. So these are all negative reviews, likely, yes. And so we can go on assigning labels to our documents. Once we are confident that, by looking at suggestions, that our automatic classification model is performing sufficiently well, we can ask for an automatic classification. So this is the only part in which we explicitly call for the machine learning method to assign label to document. Assigning label does not mean that we record those label assignment as true labels or as blue labels on the interface. We just get this automatically assigned label as some information that we can download then to use in other text mining process, or then to review and re-upload as ground truth information. So once we are in the automatic classification page, we can ask for a new automatic classification. We select the classifier. Right now we are just sentiment, so the data set is already selected, and we hit classify. So what happened in background, all the 25,000 documents of the dataset are automatically labeled. Well, not all. Those that have not been manually labeled, and we will see that those that have been manually labeled will be marked in the file we download as being manually labeled, so that we can tell what is very human quality annotation or what is machine quality annotation. So here in this page you see that the process is running, and we can move around and do other things, and then we can go back here and go to the classify page to check how it is going on. So this is running. 25,000 documents may require a bit of time to be labeled, and so we can wait a bit more for this process to complete. So the labeling, the automatic classification task is complete, and we can see that it took a bit more than 2 minutes to automatically classify the whole data set, and now we can download the labeled document. So in the data set itself here on ICS, on the system, is not changed. The classifier itself is not changed. What we have is a copy of the dataset automatically classified by the sentiment classifier, as we can see here, available to be downloaded in CSV format. So we click download and we get this file. We can show it. And the name of the file tells us that this is the dataset IMDb English classified by the sentiment classifiers, and this is the date the classification happened. And so we can open this file on any editor, or we can import it into any spreadsheet application. And so you can see that what we have here is the unique ID of the document, so that we can link it to external resource. Then we have the content, and last we have the label assignment. And the label assignment is in the form name of the classifier, label assigned, and then we have this backslash h, or we can see here backslash m, which means assigned by human or assigned by machine. So most of the cases, if we search for these, we will see that there are many of these backslash m entries, and you see 24,841. So most of the documents have been labeled automatically by the machine, but so the backslash h information tells which are the gold label that have been produced by humans, so you trust them more than the machine learning, obviously. And so this is our automatically classified dataset. We can close this. And for example, you can ask right now for the classification of sentiment of IMDb by sentiment, and you'll get that message that tells you that an up-to-date classification is already available, because we have not provided any new example to the model. So the model that produced this classification is not changed, so you would get exactly the same output. If we go to the dataset and we do label a few, even a single one more, document. Okay, it's in a positive view. So okay, we have changed a single document. Then if we go and we ask for an automatic classification, we'll get a new classification. This one is done, this one is pending and then running. So in a couple of minutes it will be ready. So this is these two automatic classification will likely differ by a few labels assigned, because the model is a different one. And so this allows us also to measure how the machine learning model evolves, as long as we provide the model with new training examples. And so these are the three modes in which we can assign labels to documents. Two of them are manual modes, browsing code and live classification, and that have two effects. We assign labels to document, and we provide training example to the machine learning algorithm. And then we have the third model, which is the automatic classification, in which we use the machine learning algorithm to produce automatic classification, to assign labels automatically to documents.